Greetings, it's Mike from Modern Retro Dev. Today I'm going to talk about a project and where I take one of these, a Raspberry Pi, and we're going to turn it into the closest thing you can get to a modern retro system. Stay tuned. So when I first started getting into the retro and modern retro scene, I was, contemplating buying this hardware and buying that hardware, and some people I knew would give some degree of pushback. Why are you buying an overpriced, underpowered system? All the stuff you want to do, you could just do that on a Raspberry Pi. That's true. That's certainly something that you can do, and I contemplated and I have emulated the systems before, but I'm still of the opinion that the physical hardware is the best way to go. But I figured if we're going to go engage in this thought experiment, let's take it to the limit and let's see how good we can make the experience of running modern retro emulators on Raspberry Pis like this. And since I like code development, I'm going to see how easy I can make it to set this up and really get something that'll give you the feel. And my hope here is to make the entry into this modern retro scene as easy and approachable as possible, so that, one of you guys out there sitting on one of these Raspberry Pi 400 or 500 or 4 or 5, you got a few hours on the weekend, you can test this out and see what you think. Maybe you enjoy it. And if you do, hope you'll join in the communities and the Discords. Consider getting some physical hardware, supporting these various projects. But this has been a longer video to develop. Probably took me a month and a half, 2 months, because there were a lot of interesting things that happened. And even though this video is going to run longer than I would typically like to aim for, it's important that it is longer because there's 3 things I want to talk about. First, I want to talk about what it is that I'm going to do, and then I want to show you what it actually does. And then the third thing is I will talk about how I did it. Because if I just tell you how I did something that I didn't show you, I don't think that's interesting. So anyway, all 3 of the things are there together. If you're not as keen on demonstrations, feel free to hop ahead to the part where I tell you how I did it, but I think it will be most interesting if you watch it in sequence. So anyhow, without further ado, let's hop into this. Okay, so I'm going to show how to use this code that I constructed here. It's called RetroVeneer, and we can get it from my GitHub website or GitHub profile, whatever. GitHub Modern Retro Dev, assuming the internet works. Looks promising. Okay, so here's the project, RetroVeneer. And I am running this on a Raspberry Pi 400 right now. I was just thinking to myself, this seems a little bit slower than I remember, but that's because I did most of my development on a Raspberry Pi 5. So anyhow, we can go over all the details of how this works later, but basically I came up with a single line installer, which is this nasty command here. This will start the process of getting this thing installed on a Raspberry Pi that just has Raspberry Pi OS on it. I've done nothing else. I installed Raspberry Pi OS and I updated it, and now we should be able to get this to work. So we'll just copy and paste this into the terminal. There's no requirements for root on this. It's just going to run as a user, and let's do it. All right. So before it gets going, there's a license. Since I am going to be installing stuff on a system, I don't want to screw it up. So I just want you guys to admit or agree to the fact that you were, taking into consideration running this on your system. So once you agree and hit enter, then it will download the installer. And here's the installer running. this should all go very quickly. The installer is going to fetch all the emulators or platform emulators that I currently have support for, and then it's also going to grab the user interface that I created for this code. So once you get this thing installed, you need to pick the platform that you want the system to mimic, and you can change this at a later date if you so choose. For right now, I'm going to go with TIC80 just so you can see what this looks like. So just hit enter. This is the configuration tool for this code that I've come up with. Basically, you can pick a platform. You can decide whether or not you want it to auto start when the system starts. Just hitting enter on this will enable or disable it. There's an option to run updates. If we check this, it should be up to date since we just installed it. There's additional stuff here, but we'll go ahead and launch this so you can see what it looks like, and this should basically pop us into TIC80. Okay, so this is TIC80. And I will go over more how to use this platform a little bit later into the video, but we can basically hop in here and pick something cool, like I like 8-Bit Panda, for example. So this thing will like download the game or application or demo and fire it up immediately. So the way that this RetroVeneer is set up is once it actually gets running, it will basically relaunch the platform emulator the moment that it is exited. And this is to replicate that the method that you would use an 8-bit microcomputer. They were never really designed to work in between one program and the next. So after you're done running a program, you just restart it and load the next one. So if you're using TIC80, there's really no need to do that. You can always just hit escape and load a different one, and it'll switch between it. However, if you're using a different platform emulator, you would need to kill it. So we can do that by holding Alt and hitting F4. That'll kill the code. And if this works as advertised, there we go. It starts it up again. Okay, so that is what this thing is supposed to do. So I will, because we do have this thing set to auto start, I'm just going to go ahead and make a new tab. And I'll just do sudo reboot. Okay, so due to technical difficulties, namely, I was not able to get the capture card to track the Raspberry Pi after restarting. I guess there's too many video mode changes. And anyway, so for the sake of this demonstration, I'm going to switch over to an emulated system here. So now I'm emulating an X86 64 system running Pop! OS. So while technically speaking, you can run this software system on X86 systems, that is not exactly what I intended for it. But certainly if you have one of those little 1-liter desktops, you can do this. So anyhow, I repeated the steps that you saw in the Raspberry Pi demonstration just moments earlier. So let me go about restarting this system, and hopefully I'll have better success here. Oh, really? You're gonna make me put this in? Okay, cool. So when you restart the system, you're gonna see this countdown. It'll give you 10 seconds to either reconfigure the system, or it will just dump you right into the emulator. So in this case, we had it dump us right into the emulator. That's fine. And like before, if we kill this, it will just restart it. That is the intended behavior of this. So I will, because unfortunately, I designed this thing so my kids can work with it. It can be kind of like foolproof, so they can't goof it up. So once you get it into the state, you need to reboot the system to get it back where you want. So let me just get this thing restarted again. And we will do a little bit of reconfiguration here. I'll show you a different system. I'll show you some of the other features on it. So my thought here is eventually I want to add support for other modern retro systems, but just to sort of demonstrate what I've got, I wanted to start with a couple that I'm more familiar with. So I selected TIC80 and the Commander X16 platform. I've used those. So let me go ahead and hit escape in this window, and this will basically pop us into that configuration page you saw earlier. So I guess I can show a couple more things before I actually go launch this other thing. So, and there are some for example, if we go to about down here in the directories page, this will tell you kind of where important directories are used for this code. So within the home directory, it will create a folder called RetroVeneer, and inside of that, there's a few different things. So you have your data directories here. So you have TIC80 and X16 EMU because those are the two platforms that installed. And then also the emulators get installed to these locations. So here's your X16 emulation, and the other one is your TIC80 installation. And the actual archives that are installed from are located in the archives directory. So if you wanted to make data accessible to these systems, you basically just put them into these respective folders. So I guess we can try and do this right now. I'm doing a live demonstration here, so of course this is going to go great. We're going to go check out the Commander X16 forums here. I'll show you how to get a game that I'm fond of. So we can go over here to forums and downloads, I believe, games. Let's see, what's one that I like? This Warlock's Dungeon is pretty cool. Pixius is currently my favorite game for this platform. So, if you've never used Commander X16 before, basically, most of your stuff gets distributed just by downloading zips. So I'm going to put this into the X16 EMU folder. I'll extract it here. So now there's a Pixius folder. And if I recall correctly, this system doesn't really behave super well with lowercase file names. So we're just going to rename that one right now. And I'm going to move this. Oh, you know what? We'll just delete it since I kept the copy. Okay, so we've put something in there. So technically speaking, if this is working as advertised, then it should show up there. So we're going to switch over to the Commander X16 platform, and then we are going to go ahead and launch this. Okay, so here we are in the Commander X16 platform emulator. We can go ahead and hit F7 to list the directory, and as you can see here, we've got that Pixius folder, which means the that auto-generated, or that folder created in installation time is correctly mapped to the drive once you start up the platform emulator. So we can go ahead and change directories into Pixius, and we can list this directory as well. And I think it was called Pixius. Shame on me if it's not. And then we could type run. Try not do this right. Oh, I see. Pixius.prg. Shame on me, man. Load. Pixius.prg. Load. Pixius.prg.01. Run. Load. Pixius.prg. Okay, there we go. Good golly. Okay, so here's Pixius. I probably totally should have stopped playing the music on this, because, yeah, anyway, great game. Let me go ahead and get this thing killed. Okay, so let's go ahead and hop back in here. So we're going to do @cd Pixius, and we're going to do load pixius.prg and run. Okay, so here's Pixius, and I'm going to try and play this on the keyboard, which it's going to be like the worst experience ever, because I'm terrible at it, but just want to give you guys an example of what this thing looks like. Hopefully this is not picking up too much of the music, because it's not my music. It's a soundtrack made by this guy that goes by the name Crisps. Fantastic soundtrack. But it's just a little Metroidvania game. You can take a couple of shots where you get killed. Quite fun stuff. You want to pick up fuel, you want to pick up gold and some other things, and just generally don't die. So I'm not gonna play too much of this, but you can at least see kind of what it looks like. See me get wrecked. Woo! Anyway, very fun. I'd highly recommend you check it out if you get the chance. Okay, so let's say, for example, you had RetroVeneer running and you exited it because you wanted to put some new games or applications in those application folders. If you wanted to then restart RetroVeneer without restarting your system, as part of the installation process, it will actually create a desktop shortcut thing. So you can always navigate to it and launch it in that way. So in this case, we can, for example, switch back over to TIC80. And I can fire up a game there and we can look at that. So let's take a look. So TIC80 has this really cool built-in thing called Surf. It allows you to basically navigate a bunch of games, demos, and other things directly off of their hosted website. So also you can develop your own games locally, or you can copy them off the website and chuck them into that folder, just like I showed you in the Commander X16 demo. So I will look at this 8-Bit Panda game. I tried launching it on the Raspberry Pi, which unfortunately right now I'm having a bit of an issue with TIC80 on the Raspberry Pi. There seems to be some sort of an issue with let me turn down the volume here a little bit. It seems to be having a bit of an issue with, actually let me just mute this. There's a bit of an issue with the current release. And I've been talking with the TIC80 folks on Discord, and it sounds like they've got a solution in the works. And seeing as RetroVeneer does include a capability to like allow people to update their systems, I should be able to add that updated version of TIC80 for ARM 64-bit ARM architecture when it becomes available. And then people can have it running on their systems. But just for right now, I want to show you guys what this looks like. This is 8-Bit Panda. It is a Mario-esque platformer. It starts off quite easy, and it then gets quite hard. And so I will give it a shot here. All right, there's the jump, there's the attack. Also a pretty cool soundtrack, and it's really quite impressive once you've got a chance to actually work with TIC80 to see really how much they're packing in, is you get about, I think it's 64K for the code of the program, and you don't really get too much in the way of, what do you call it? there's not that much room for like sprites and all that other stuff. So, oh well, or you could just go and get killed. Like I'm getting killed. And hey, there's the exit. So cool. I cleared a level. There's a bunch of other interesting games. Let me see if I can find one more. Let's see. So I've also, in a former video, called out this Balmung. Fantastic game. Should totally check it out if you get a chance. Another one, and this is really not a complete game. I'm assuming they ran out of space on this, but the music on this bare bones game is pretty sick. Fantastic music. So if you get a chance, check that one out. Let's see, what other do I like? This Portal Tick 80, it's very impressive. I play with inverted y-axis, so I can't just play this from the get-go, but it's a fairly faithful interpretation, or what did they, I forget what that term is when they sort of like, but yeah, it's Portal 1, pretty well done. I guess we can look at Stella, which is just kind of a Celeste clone thing. Anyway, there's a lot of games on here that are pretty interesting. If you get a chance, go check them out. Oh, there we go. We got the little like thing here. Also a very fun development platform. So, all right, I'm going to stop here. So anyhow, that's a pretty good rundown of what RetroVeneer does and how I intended it to work. The only other thing that I definitely want to do to it that isn't completely done yet is I do want to add support for some other modern retro systems. The two to come to mind right now, one is the Foenix F256 platform. I'm now a new proud owner of a F256 Junior. Haven't had a chance to play with it too much, but this is a fun platform I want to take a closer look at. And I've been in talks with another guy that's developing this other project called the X65, which I'm also quite interested in. So anyhow, that's the overview. Next, I'll start diving into how I actually went about constructing the code. I learned a lot of new things along the way. That's part of the reason it took so long, but I would say how the code was developed is as interesting a part of the story as how it actually works. So, hope you enjoy it. Okay, so I wanted to spend a moment delving into the details regarding how I designed RetroVeneer. First, I want to start by taking a look at the tools that were used in its development. It was written mostly using Rust with some Bash. The user interface I developed using a library called Raylib. And the applications, well, things not scripts that I created were packaged using a using AppImage. So the workflow for RetroVeneer looks like this. There is an initial bootstrap script, which is written in Bash, and when you run that, it will basically pull in the installer. And the installer is a program written in Rust, and then Rust with Raylib packaged into an app image. And the RetroVeneer installer will grab all the emulators, and it will also grab the RetroVeneer user interface. The RetroVeneer user interface is also developed in Rust with Raylib and packaged using AppImage. And RetroVeneer will launch the platform emulators. So the stuff you see within the blue dashed line, that constitutes what is RetroVeneer, whereas the platform emulators exist outside of that. So regarding why I opted to use Bash and Rust, Bash, there's really one good reason to do it, and that it is everywhere. If you are, for me to sort of satisfy that it just works, part of the project, I had to basically start with Bash because I know it's going to be there. Rust. It is a very expressive compiled language. I'm semi-new to using it. I've used it for a few years, but not super extensively. But it allows me to get things done a lot more quickly than if I were doing the equivalent thing in C, but it is still compiled. Another very important aspect of this is the modern tooling, and a big part of this is Cargo, which is their like package building. It's the part of the code that builds packages, and it's phenomenal. In my current experience, I would say it is best in class. Another reason that I selected Rust is there is a large set of libraries available for use. You can browse this yourself if you check crates.io. So regarding the selection of Raylib and AppImage, with Raylib, which I guess I'll give a little bit of background, it's kind of something similar to SDL. It's a user interface creating library, but it is more low level. So you could likely use it to write a video game or something like that. But it seems to be a lot simpler to use and lighter weight. And since I was new to it, I wanted an excuse to write something with it. So I used it. Oh man, I just mentioned this. It is lightweight, and at least from my preliminary experience, it seems a bit easier to use than SDL. Now regarding AppImage. AppImage was another new technology to me. I say new, I've used it as an end user. I've never tried to package something with it. So this was an experiment to learn about that. And what I can now say, having worked with it, is it's fantastic. And I think it really resolves one of the big sticking points I've had with Linux in general, is that it's great for developers, but it's kind of terrible for end users. So this ability to package things really well, I think, sort of bridges that gap and resolves one of the issues I have in the Linux ecosystem. Also, the fact that it requires zero setup for end users is huge. I like and use Flatpak all the time. However, if your system is not set up with it, then there's technical stuff that has to happen. And I don't really like snaps, so I'm not even going to talk about that. But of those three options, AppImage is the only one that you could just like throw at a system and have it work. Let's see. Oh, right. Post-mortem. So there are some reasons why this took me almost 2 months to put together. There were some pretty significant bumps that I kept hitting that slowed me down. I guess you could say those were learning opportunities. But takeaways here. Making easy to use software is very difficult. And I'm not really going to go into the details of this a lot, but it involves a lot of testing and a lot of, oh, hey, it should just do this. And then adding all of those little things takes a lot of time, but there it is. My initial assessment on Raylib seems awesome. I do plan on using it again. Some of the other things I would formally write with SDL, I'm going to try writing them with Raylib because it was a very positive experience. I will echo that sentiment regarding AppImage. I also thought this was awesome technology. I do plan on using it again. It's a little bit of, there's a little bit of a learning curve for building it as a developer, but once you figure it out, it's very seamless to use. And, if you're on the fence, please feel free to check my GitHub. You can see how I was building these things. It's not that hard. And once you figure it out, it's easy and it's great to deploy. Another thing I learned, Rust cargo build system is way better than I thought it was. I adopted use of Go way back when it was brand new, and I thought the package management for Go was amazing. But as time went on, I did see some places where it caused a lot of problems, and I'm not going to go into all the details on those, but I will say that Cargo as a similar tool resolves all the issues that I had with Go packaging, at least in its nascent form. I'm sure it's much better now, but all I'm saying is this is fantastic tech. Also, one of the things I learned out of this was how you go about doing auto start of Linux applications. And basically it comes down to there being like a .config folder within the user's home directory, and then if there's an auto start folder within that, you can put .desktop files in there, and it will just launch them when the user logs in. It's pretty simple. The trickiest part is actually constructing the .desktop files correctly. I screwed that up I don't know how many times. So anyway, there's sort of the lessons learned there. I definitely got burned by a few things, so let me just kind of gloss over those here. So I had some cases where I was getting straight up compilation issues with the raylib sys package when compiling an ARM architecture 64-bit, and I was not seeing those same issues when compiling it on x86 64. And it was a bit of a head scratcher. And I didn't want to have to like delve down into, you know, fixing a broken package or a broken library, because that was not my project. So this one I spent a little time looking into. And the resolution for this was I figured out how to build a specific version of raylib from the Git repository targeting a branch and a specific commit from it. And to my amazement, it is very easy to do this with Cargo. So this saved my bacon. Another thing that burnt me a little bit was I got the Rust Raylib ARch64 app built and running on the dev system, only to find it wouldn't work on a fresh install of Raspberry Pi OS. So this one I wasn't expecting, because one of the selling points of AppImage is that it'll grab all the dependencies that your application needs and package it in together. And yet it still wasn't running, and not very good error messages either. It just kind of crashed. So upon doing some looking, what I determined, well, let me just push the button here. What was happening is that the default compilation of raylib-sys was sort of auto-detecting which version of OpenGL it could use, and it was grabbing something that was available once all the packages were installed for development, but were not available in that Raspberry Pi OS vanilla installation state. So I basically had to tell Raylib to explicitly target a more simplistic OpenGL ES2 instead of like runtime determination. And once again, this was actually something I could do completely within like that Cargo configuration file. So like I said, hats off to the Rust team and Cargo. It's phenomenal. So that pretty much wraps up what I wanted to show this time around regarding RetroVeneer. But I would like to hear if you guys have feedback, things that can be made better. Certainly, if you get an opportunity, give it a shot. Let me know what you think. I hope you enjoy it. I think next time around I will probably revisit the compiler project I was working on. I only showed off about half of what I had been working on because it was getting a little long. But I'll probably get back to the unit testing and some other stuff. So I think it should be fun. So anyhow, with that, I'm going to wrap up this video today. Thanks for watching. And, you know, this is my cue to get back to some modern retro dev.